Today, we're going to pull back the curtain on a hidden force that pretty much governs our world. It's something I like to call the invisible rule. So let's just dive right in. What in the world do these three things have in common? An airplane wing, a perfume bottle, and a baseball pitcher's curveball. I mean, they seem totally unrelated, right? Well, what if I told you they're all connected by the exact same single principle? That's right. One simple, kind of elegant, and, well, invisible rule of physics is the secret sauce behind how all of them work. And trust me, by the end of this, you're going to start seeing it absolutely everywhere. All right, so what is this mysterious invisible rule? Let's break down the core principle behind it all. It's called Bernoulli's principle, named after the Swiss mathematician Daniel Bernoulli. But the idea itself is beautifully simple. It just says that as the speed of a fluid increases, the pressure it exerts decreases. And a quick heads up, in physics, when we say fluid, we don't just mean water, we mean anything that flows. So air totally counts. Now, for the physicists watching, here's the formal equation. Yeah, it looks a little intense, I know. It's all about conserving energy, balancing pressure, kinetic energy, and all that. But here is the great news for everyone else. You can absolutely ignore this. You do not need to memorize this formula to get the big idea here. So all you really need to remember is this one simple phrase. This is our mantra for today, okay? Faster fluid equals lower pressure. That's it. That's the heart of it all. Faster fluid, lower pressure. So here it is laid out. Where the fluid is moving fast, you get lower pressure. Where it's moving slow, you get higher pressure. And it's that difference between the high and the low, well, that's where all the magic happens. So where can we see this in action? Let's start with the biggest, most mind-blowing example. How does a giant 400-ton metal tube actually get off the ground? The whole secret is hidden in the shape of the airplane's wing. It's called an airfoil. And look at it. Its design is incredibly clever and totally on purpose. It's more curved on the top and relatively flat on the bottom. Okay, just think about it. As the wing cuts through the air splits. The air going over the top has a longer, curvier path to take than the air going straight across the bottom. So for both streams to meet up at the back at the same time, the air on top has to move faster. And what's our mantra? Faster fluid means lower pressure. So you get a zone of low pressure above the wing and a zone of higher pressure below it. And what happens when you have high pressure pushing up from the bottom and low pressure, well, not pushing down so hard from the top? You get an upward push. And that, my friends, is called lift. It's the force that literally shoves a massive plane right up into the sky. Pure Bernoulli. Okay, let's go from a jumbo jet all the way down to your bathroom counter. A simple spray bottle? It works on the exact same principle. When you squeeze the pump, you force a jet of air to move at high speed over that little tube. And that fast air creates a low pressure zone. The normal, higher pressure inside the bottle then pushes the liquid up the tube and poof, out comes a fine spray. It's Bernoulli's principle, right in the palm of your hand. And once you really get this, you start to realize this isn't just for a few special cases. This principle is, well, it's everywhere. Do you ever wonder why smoke goes up a chimney instead of just filling up the room? When wind blows across the top, that moving air has lower pressure than the still high-pressure air inside the house. So the higher pressure inside just pushes the smoke right up and out. Or here's a much more dramatic example. During a hurricane, you have incredibly fast winds whipping over the roof of a house. This creates a huge zone of low pressure outside, but inside, the pressure is still normal and high. That difference can be so great that the high pressure inside actually pushes the roof clean off from the inside out. And that curveball? Same deal. When a pitcher puts a spin on the ball, one side spins with the airflow, making the air speed up. The other side spins against it, slowing the air down. So what do you get? Low pressure on the fast side, high pressure on the slow side, and that difference pushes the ball, making it curve. See? It all comes back to this one fundamental idea, the key to everything we've looked at. Wherever a fluid moves faster, its pressure drops. Honestly, by understanding this one simple rule, you've pretty much gained a new superpower. The ability to see the invisible forces that are pushing and pulling on the world all around you. So, what's the big takeaway here? At its core, yes, Bernoulli's principle is about energy balance. But the thing to burn into your brain is our mantra: faster fluids mean less pressure. Once you've got that, you can unlock the secrets of flight, you can explain a simple spray bottle, you can even understand the physics behind a wicked curveball. It's this fundamental force hiding in plain sight, constantly shaping everything. And that brings us to the final question, which is for you. Now that you're in on the secret, now that you can see this invisible rule, where else are you going to spot it today? Look around. I promise you'll be surprised where it pops up.